Welcome to this video on rational and irrational numbers. By the end of this video, you should be able to differentiate between a rational number or an irrational number and know the perfect squares up to 15. Alright, so types of numbers. Throughout your schooling career, we have talked about you've been told about different kinds of numbers. When you first started school and you were in kindergarten, we started counting often starting at 1, the counting numbers that's greater than 0 but doesn't include 0. So 1, 2, 3, and we could keep counting to the right. So that's what these 3 dots means. It means you could keep going in that direction. So those counting numbers are called natural numbers. That's what we counted with when we were much younger. Then we added to the counting numbers 0. So instead of starting at 1, we started counting at 0, and we can keep counting to the right, to the more positive, and we call these whole numbers. All right. Now, building onto that, so we started with this set, we expanded it just a little bit more. We're going to expand it now to something called an integer. So an integer is the set of whole numbers. So 0, 1, 2, 3 to the right, we can keep going, and their opposites, meaning including the negatives. And we can keep counting in this direction. So those are our integers. And then from our integers, we can build into this next set. So any number that can be expressed as a divided by b, so a fraction, where a and b are integers, meaning these numbers up here, but b does not equal 0, because you can't divide by 0. These are all called rational numbers. And that's a lot of what we're going to be talking about today. And ultimately, we're going to be comparing and determining the difference between a rational and an irrational number. So the set of numbers that include all rational and irrational numbers they're called real numbers. Okay, so let's talk a little bit more about rational and irrational, because that's what we want to be. We want to be able to identify numbers as either rational or irrational. So let's flip this over. And we have both of these together. We have our rational numbers. So our rational numbers, if somebody is said to be rational, they're kind of more normal. These are the more normal looking numbers like you're used to seeing on a daily basis. So I'm going to give you examples of all kinds of rational numbers. So proper fractions. A proper fraction is where the numerator is smaller than the denominator, like 1/2, 3/4, 2/5. All of these, the top is larger than the bottom, or smaller than the bottom, which makes them a proper fraction. Improper fraction is when the numerator is greater than the denominator. So like 12/5, 5/4, 9/8. The top number is bigger than the smaller number. Okay, so in middle school, a lot of times what would happen is you would be asked to take an improper fraction and write it as a mixed number. So what a mixed number is, you look to see how many times the denominator goes into the numerator. So 5 goes into 12 2 times, and that takes it to 10, which means there's 2 more left over, and you would write the rest as a fraction. Okay, 4 would go into 5 once with 1 left over, so 1 1/4. Okay, or any of these are examples of mixed fractions, mixed numbers, where you have a number and a fraction written together. Okay, then we're throwing back rational numbers. Our integers, remember those were the set of whole numbers, so we could include 0, we can include positive numbers, we have 5,000, but we also have to include negative numbers, -100, -73. Okay, so positive and negative numbers are your integers. Now here's where it really comes down to, you want to pay attention to about your decimals, because both rational and irrational numbers have important information about their decimals. A repeating decimal is that you're repeating the same digits over and over and over again. So we could just be repeating one digit, and a lot of time you'd see that with a bar over it. But you could also be repeating more than one digit. I could be repeating the same exact thing, 212121. That would be a repeating decimal. 0.657657. The 657 is repeating. Okay, so that's repeating. You're going to see the same number repeated over and over and over again. It could be a 1-digit number, a 2-digit number, a 3-digit numbers. You're just kind of looking. And then our last one is terminating. Terminating means it stops. Okay, a terminating decimal. So 3. 5.97. If they didn't go forever, they stopped. 0.752. 9.64. Okay, so you go a couple decimal places and it's going to stop. It doesn't go on forever and ever. So a terminating decimal is a decimal with a finite, meaning ending number of decimal places. It will end. It will not go on forever and ever. And then a repeating decimal is a decimal with one or more digits that repeat without limit. So we could say 0.2 and then you'll have the ellipses, ... meaning that's going to go on forever, but it's going to be this forever and ever and ever. 0.657 with a line over it, ... meaning it's just going to repeat forever and ever and ever. 0.657, 657, 657, 657. Okay, so these are rational numbers. Irrational numbers are going to look a little bit crazy. Okay, so they look a little bit different sometimes. And so that's what we want to remember. So irrational numbers are numbers that cannot be written as a ratio of two integers. And so think ratio, think fraction. It cannot be written as a ratio of two integers. Remember integers over here. Okay, that's what we're saying here. So if we were to take the square root of a non-perfect square, we would end up with a non-repeating and non-terminating decimal. So that would be irrational. See how we're saying non-repeating, non-terminating is irrational, while repeating and terminating is rational. Those are important to remember. And if a decimal is a non-repeating and non-terminating, it means it's called irrational. So let's give you some examples here. Irrational numbers. If I have a square root with, say, a 14 in it, 14 is not a perfect square, so the square root of 14 is irrational. The most famous irrational number of all, pi. It goes on, they've taken it out a million decimal places without a repeating number, like a pattern repeating. We could have 4.12131415. We're seeing a pattern, but it's not the same number repeated again and again and again. 12 is different from 13, which is different from 14, which is different from 15, and it's going on. So it's non-terminating, non-repeating. Okay, I do want to put in here, let's go with another example over here for irrational. You could have the square root of a perfect square. So 25 is a perfect square. The square root of 25 is just 5. That's a nice natural number or a whole number. It's an integer, so we're going to say that's rational. As opposed to the square root of 14. 14 is not a perfect square. You can't multiply the same number by itself and get 14. And so that's why it's irrational. All right, let's flip this over and try some. Okay, so our organizer, so we get an idea of how everybody fits together. We have this large circle with smaller circles in it. That means these smaller circles are part of the large circle. Every time you go in, so this circle belongs to all of these circles. Okay, so they are building within. So here at the top, the outer circle is our rational numbers. And then the thing we're comparing them to are irrational numbers. Okay, so rational numbers, let's give some examples. Like I said on the other side, if you have the square root of a perfect square, because 25 is 5 times 5, that's a perfect square, the answer would be rational. If you had a repeating decimal, that would be rational. If you have a terminating decimal, that would be rational. If you have an improper fraction made from integers, that is rational. If you have an improper fraction made from integers, that is rational. And if you have a mixed number, 2 and 1/2, that would be rational. These are all rational examples. Okay? Irrational, remember we had pi, the square root of a non-perfect number, or as we learn tomorrow, we can be simplifying and have what looks to be a mixed number that still has a radical on it. That would also be irrational. Okay, so within our irrational numbers, we have a subset called integers. All right, and integers, remember, are that you can go all the way left and you could go all the way right, and it's your negative numbers, 1, 0, and then your positive numbers. Those are integers. Then we have whole numbers. And whole numbers is a smaller set than integers. Remember, the whole numbers don't include the negatives, so they're the 0, 1, 2, 3, and we can keep counting to the right only for whole numbers. And then the smallest set of them all is the natural numbers. Okay, so natural numbers, the only difference between whole numbers and natural numbers is natural numbers start at 1. Okay, now let's try a couple of examples before you do your practice. All right, so using the notes that we've got, go back to the page. This is where I'm going to recommend you flip back to, is the page that had rational and irrational on them together. So the one that looks like this, to help you with this. So we have 0.875, and I'm saying it's some kind of decimal. Well, 0.875 stops. It doesn't keep going. There's no ellipses here. So this is what we call a terminating decimal. And if it's a terminating decimal, that means it's rational. Okay, let's try it again. Look at 0.4 with a bar over it. That means it's repeating. Okay, so this is a repeating decimal. Repeating decimals are rational. Now, look at the third one. It's got ellipses on it, meaning it's going on and on. It's non-terminating, so we know it's not going to stop. So we're going to say non-terminating. And when I look at it, it's not repeating the same number, because we've got a 20, then a 200, then a 2000. There's a pattern there, but it's not the same number being repeated like up here in this previous one. 4 is being repeated. So this is also non-repeating. And if you are non-terminating, non-repeating, that means that is an irrational number. Okay, now the question wants to know, is the square root of 15 rational or irrational? For it to be a rational number, the number being square rooted would have to be a perfect square. So you'd have to ask yourself, is 15 a perfect square? And the answer to that is no, 15 is not a perfect square. That means if you took the square root of 15, you would end up with an irrational number. Let's try that again. The square root of 40. Well, 40 is not a perfect square. That means the square root of 40 will be an irrational number. And then our last one, the square root of 81. Well, 81 is a perfect square. The square root of 81 is 9. 9 is a rational number, so the answer to the square root of 81 would be rational. All right, let's flip this over for some instructions on the assignment. All right, so your objective here is you're going to look at each of these numbers in this grid and just determine if they're rational or irrational and color them accordingly. You don't have to use the colors I use. So maybe you want to make your rational numbers pink and your irrational numbers purple. Some way, just indicate how you're going to color them so I'm able to look at your answers and know what you know. And then look at each one of these. Go back to your rules and decide, is it a rational number or irrational number? Color them accordingly, take a picture and upload it to the Canvas assignment. Let me know if you have any questions. Hopefully this was helpful. See you in class.